In this video, I want to work through an example that uses text boxes in an interesting way. So to start with this, I want to show you something that I use very often. I'm going to create a text box. I'm just going to put it down here in the bottom right. We'll say X, choose LaTeX formula, and hit OK. I'm going to make another text box, choose LaTeX formula again, and do Y equals f of x. You might have guessed I'm going to label my axes. So by default, if I move the graphics view around, those text boxes don't stay in a very convenient location. So first I'm going to make the text a little larger just so that we can see it. What I'm going to do now is right click on this X text, go to the object properties, and choose position. I'm going to position this text so that it stays in a very convenient location for an axis label. So what I'm going to do is I'm going to tell it where the coordinates should be, and I'm going to do X of corner 2, comma 0. I'm going to hit enter, and we notice that now we kind of see the outline of the text box down here. If we click on that and drag it up to a nice location, now as we pan the graphics view, notice how that text stays in like the perfect location right above the x-axis. In the same way, I'm going to select the Y text. I'm going to make the location 0, comma Y of corner, we'll go 3. I'm going to hit enter, and now this one's already in a pretty nice location. So if I close that out, we notice that now our axes are labeled in a very nice way. That method right there I use in a ton of my constructions. Okay, next I'm going to quickly create a few objects that I'm going to use. I'm going to use my favorite function here, f of x equals e to the sine x. I'm going to create a slider named n. We'll go from -3 to 3 in pretty small increments. And what I'm also going to do is define a number, dx. I'm going to make dx for now equal to 1. Okay, so what I'm going to do is create an initial point and a final point on this function graph based on the value of n in the value of dx. So I'm going to create a point p sub I, which stands for initial point. I'm going to do n comma f of n to put this point on the graph. Now I'm going to make another point p sub f for the final point. I'm going to make this equal to, instead of starting at n, or being at n, do n plus dx, and then f of that value, so f of n plus dx. I'll hit enter. Now we see that as we vary n, those 2 points are both on the graph of f, but they're 1 unit in x away from each other. Next, I'm going to create a couple of change vectors to represent the change in x and the change in f of x for both of those things. So I'm going to create a vector. I'm going to call it dx vec. I'm going to make that a vector that starts at p sub I, and then we want this to end at n plus dx, and then f of n. So the x coordinate of the final point will be n plus dx, but the y coordinate will be f of n. So I'm going to hit enter, and now we've got that vector right there. And similarly, I'm going to create a vector called dy vec. We'll make it a vector that starts at n plus dx f of n and ends at p sub f. Okay, cool. I'm going to pretty things up just a little bit real quickly. I'm going to make my function graph no label. I'm going to hide the label on basically everything. We'll thicken that up, make it green. These two vectors I'm also going to thicken up just so that we can see it. I'm going to hide their labels. I'm going to make one of them blue and then one of them red. And then these 2 points look pretty good, except we're going to hide the labels. Okay, so now we see that as we vary our slider n, we have the change in x and change in y represented by these vectors. Okay, so last thing, we're going to put text representing the value of the change in x and the value in of the change in y. So we'll use the text tool. In this first one, we're going to do delta x backslash delta x equals, and then I'm going to select an empty box. And in this empty box, I'm going to put dx because that's the GeoGebra variable representing the change in x. I'll hit OK, and we've already got that text there, which is nice. Next, I'm going to make another text box, use the LaTeX formula, do delta f of x equals, and now we need to use an empty box and actually compute this change in output. And the change in output is going to be f of n plus dx minus f of n. And make sure you understand that math. I won't discuss it here. I'll hit OK. And now we notice we've got these two texts. And the change in x is fixed, but that change in f of x is going to vary. Okay, so one last thing. I'm going to make sure that these are positioned in a nice location. So we'll go to the object properties of delta x. In this, we'll do n plus 0.5 times dx, and then f of n. Cool. I'll adjust that slightly, make it a medium-sized text, and I'm going to change the color of that to blue. Okay, now the change in f of x, the position for this, I'm going to do n plus dx, comma, 0.5 times f of n plus f of n plus dx. That's going to put it halfway down this vector. I'm going to make this a little larger as well, and I'm going to make that text red. All right. Now we've got this slider n, and as we vary n, notice that dx and df of x are going to vary accordingly. Now the very, very cool thing about this is maybe we change dx to be 1.5. Now everything adjusts accordingly, and all of our calculations are going to be the same. All we had to do was change one value. In a similar way, we could do something like f of x equals cosine of x and change the function definition, and now we have the same thing going on, but we changed the definition of our function.